A sonometer wire is stretched by a hanging metal bob. Its fundamental frequency is F1. When the bob is completely immersed in water, the frequency becomes F2. Find the relative density of the metal. Right. To do this question, we need couple of equations. First equation we need here is fundamental frequency of a stretched string F naught or F1 equals 1 over 2L root T over M. So here we should know T is tension, M is the mass per unit length, and L we have taken as the length of the wire. So we only take up to say point A to point B length is a L, right? So let's apply the first equation here for this situation. So we can write again F naught equals 1 over 2L. So here the tension is equal to mg. So we can write mg here for T, but here we have to relate density into this thing. So we can write mg in terms of density. So another equation we need here, it's density equals mass divided by volume. So mass equals density into volume. So I can write here the volume is V and density of the metal bob, let's take it as rho. So V rho G. So I can write here V rho G, that is divided by mass per unit length, right, M. So we have our first equation. So let's get into the second scenario. Here it is immersed in a liquid, that is water, density rho W. So in the question they are asking us to find relative density. Again, relative density is equal to rho divided by rho W. So this is our answer, right? So let's write F new F is equal to 1 over 2L, that won't change. Now the tension will change. So here tension will be, so let's write the equation for the equilibrium here. So tension is equal to mg, tension plus subthrust is equal to mg. So here tension will be mg minus u. So v rho g mg minus upthrust, again we can write the immersed volume is v and density of water rho w g divided by again m, the second equation. So here what we can do is we can divide first equation by the second equation. So this is the first equation we have found and this is the second equation. My bad, this is the second equation, right? So let's divide these two. So when dividing these two, so I can write F2 here. So F1 divided by F2, 1 or 2L will cancel off and we get the root value. So in order to remove the root values, we can square these values. So I can get F2 squared and F1 squared. So F1 squared, F2 squared. So here I'll be getting V rho G minus, right? Now we have these two equations. So let's divide these two, then we can get to our answer. So initially we had to remove this root value. So I'm going to square these values. So I'm getting f1 square equals 1 over 2L root V. Again I won't be having root, then V rho G divided by M, first equation, and f2 squared equals 1 over 2L V rho G minus V rho WG over M divided second answer, second, right? So when now I can divide these two, right? So when I divide these two, I'm getting f1 squared divided by f2 squared equals, so 1 over 12, 1 over 12 will cancel off. Again V is common, that will cancel off, and simple G is common and M is common. So after dividing, I'm getting rho divided by rho minus rho W here, right? So our plan is to find rho divided by rho W, right? So let's do the cross multiplication. I'm getting f1 squared into rho minus rho W equals f2 squared rho. So I'll remove the bracket. F1 squared rho minus F1 squared rho W equals F 2 squared rho. So I can get rho into one side and rho w to the other side. So I'm getting f1 squared rho minus f2 squared rho equals f1 squared rho w. So I'm getting rho f1 squared minus f2 squared. So here we are getting the answer f1 squared divided by f1 squared minus f2 squared. So in our answers is the first one here. The first one is the answer. Alright students, if you think this is valuable and helpful, share it with your friends, study together and win together.